Alright, we are back. We are going to be finishing off our 3-6 Proving Angle Relationships notes here. We completed part 1, we completed question number 1 and question number 4 of this assignment already. We're now going to do question 7, and we're going to do the test review. We're told here angles H and I are supplementary, and H and J are supplementary. We want to complete the proof that angle I and angle J are congruent. So they're starting off with angle H and angle I are supplementary. Where did we get that? Well, we were given that. We'll have given as our first reason. We'll also have given as our second reason. These two lines are told to us right here. H and I are supplementary, H and J are supplementary, were told to us here and here. Now, they're saying H and I equal 180. Measure of angle H plus measure of I equals 180, and the measure of angle H plus the measure of angle J equals 180. Where is that coming from? Well, remember what it means to be supplementary. If we flip over and take a look at our supplement theorem, if two angles form a linear pair, we say they're supplementary, we say they add to 180. If things are supplementary, they add to 180. That's basically our definition of supplementary angles. This is what IXL would want, definition of supplementary angles. Your book might call for supplement theorem. You can see different language depending on which book or program you're using. But we would say that it's the definition of supplementary angles. There was a very good question asked of some people who've already completed this, asking me some questions about why aren't we using linear pairs like we did on number 1 here. The best reason I can give for why we're using the definition of supplementary angles and not angles forming a linear pair sum to 180 is we don't have a picture. Here in our picture, we see the two angles are actually making a straight line. So we know that they make 180 degrees. Here, I'm told H and I are supplementary, but I'm not seeing any picture that they're making a straight line. I could have an angle H right here and an angle I physically separate. These two aren't physically making a straight line, but they could still be supplementary depending on their values, say 30 and 150. I don't have a straight line visual here. I've got a ray, and another ray. Just because they're supplementary doesn't mean the picture is making a straight line just yet. What we can say is that they add to make 180. That's what it means to be supplementary. Next, we're saying H and I added together is the same as H and J added together. Again, we have our transitive property. We saw it twice on the other side. We're using, again, transitive property. Something I didn't mention yet, watch out, is that it's transitive property of equality. They will try and trick you on that. In some places, you'll see transitive property of congruence and transitive property of equality. IXL particularly has that. So make sure that you're using equality because we have equal signs. If we had congruence signs, like that one there, we'd be using congruence instead. You can actually use substitution here as well. Substitution does work fine. Again, proofs have multiple ways to be written. There's no one exact way to write a proof. There's fastest way to write the proofs, but there's not one exact way to get your proof. Last, we're saying the measure of angle I is the same as the measure of angle J. Well, we see that measure of angle H was on both sides, so it just disappears. We get to cancel it out. They subtracted it from both sides. You guys have seen stuff like that since Algebra 1. So we get to say, since they're subtracting angle from both sides, we're going to say that's properties of addition and all that. Properties of adding slash subtracting slash multiplying slash dividing. That's what IXL refers to it as. You would probably more specifically say subtraction property of equality. Subtraction property. Last, going from equals to congruent. How do we go from equals to congruent? That's what it means to be congruent. Things that are congruent are equal. It's our definition of congruence. So now for this IXL quiz that is due today, technically the 23rd. I'm recording this on the 23rd. But you have till the 27th to turn it in. We've done numbers 1, number 4, and number 7. We're going to do the test review. We're going to write the conditional statement here in a if-then form. Then we're going to write and identify the converse, the inverse, and the contrapositive. I did see some creative writing for this. The creative writings I saw weren't wrong. They're just not what I would have ever written. I'm going to show you what I'll be writing. If you have 4 quarters, then you can exchange for a $1 bill. I did not provide quite enough space. I thought I did. I did not. We have our if and then, and that's our original conditional statement. Let's identify the converse. Converse is we swap the order. If you can exchange quarters for a $1 bill, then you have 4 quarters. Our converse is just swapping the 2 parts. If you can exchange them for, exchange what? What's them? Quarters. For a $1 bill, then you have 4 of them. You have 4 quarters. Our inverse is taking our original statement, our conditional statement, and sticking the word not. If you don't have 4 quarters, then you cannot exchange them for a $1 bill. Contrapositive is we can take our converse, which has already been swapped, and negate it, or we can take our inverse, our third line here, our inverse, and swap it, finding the inverse's converse. If you cannot exchange quarters for a $1 bill, then you don't have 4 quarters, is what we're going to write. You can't exchange quarters for a $1 bill. I have that in the wrong order, sorry. Then you don't have 4 quarters. All right. Conditional statement, converse, inverse, contrapositive. Last, what is the volume and surface area of a cylinder with a height of 10 meters and a base diameter of 10 meters to the nearest tenth place? We'll draw a quick picture of this. Let's get our cylinder up and going. Probably not draw the best thing to represent this picture, but we'll make it make do. So they're saying the height of the cylinder has a height of 10 meters. They're saying the base diameter, the diameter across the base. Your cylinders have 2 bases, the 2 circles. The distance across the center of the circle is 10 meters. We're going to have to make use of our formulas. For volume, we've got volume is capital B, the area of the base, times the height. We'll start with that. Again, the base here is a circle. It didn't have to be circle flat on the ground. It could have been a picture to the side like this, but our base is still the circles. Your base of a cylinder or a prism is what shape you have twice, and only twice, that is parallel to one another. B being the area of the base, it's going to be the area of the circle here. Area of a circle is pi r squared. Since our diameter is 10, we know the radius is 5, so we'll have a base area of 25 pi. 5 squared times pi. That area of the base would then be multiplied by the height of the cylinder. So 25 times pi times 10. We get 250 pi, which on a calculator, let's see, is 785 point, we're into the nearest tenths place, 4, when using pi itself. So that'd be 785.4 meters cubed, because we're dealing with meters as our measurement. To find our surface area, again, go to your reference sheet. Reference sheet says it's twice the base area plus the perimeter of the shape times its height. We already know for this cylinder what the base area was. It was 25 pi. we'll have 25 times pi there. 2 times 25 times pi. What you need to remember is we also need the perimeter of that base. We need the perimeter, the distance around the circle. The distance around a circle, as a reminder, is your circumference. Perimeter is equivalent to circumference for a circle. Which is, for us, 2 times pi times the radius, or pi times the diameter. Luckily, pi times the diameter, we know the diameter is 10. So we get to replace p with 2 times pi times 5, or in this case, 10 pi. We'll have 10 times pi times, now we need the height of the cylinder. It's 100 meters, sorry, it's 10 meters. So we can do a little bit of simplification. This will be 50 pi. This will be 100 pi. Altogether, that's 150 pi. We'll multiply that in our calculator. 150 times pi. We get 471.2 meters squared, or square meters, for our surface area. That's for our notes.